All right, I'm going to now go over the mean value theorem. So this is something that you got to know for the AP exam. So let's stay focused. You ready, Pepe? Yeah. So it says that as long as f is a function that satisfies these two conditions, the first one being that it's continuous on a closed interval from a to b, and that's differentiable on the open interval. Whoa, it's differentiable between a and b. Then you can use this equation because it's going to say that there's a value between a and b, so some number between the endpoints, we're going to call this number c, such that the derivative at c is going to be equal to f of b minus f of a over b minus a. So at first this looks kind of weird, but I'm going to show you exactly what this means because it's actually pretty easy to understand once you get the idea behind the geometry of it. So again, let's just keep this in mind. F prime of c is the slope of a tangent line. This is actually just the slope between 2 points. This is just how you found the slope back in algebra and stuff. So let me show you what I mean. So I'm going to just draw a random curved function, and you'll be amazed at how this works. So let's say I'm drawing a function like this, does this sort of thing, and I'm going from, this will be a, and b is going to be over here. So here's my function f. So on this graph, this will be about a comma f of a, and then b comma f of b is going to be like somewhat over here, right? So it's continuous. As you can see, that there's not any holes or gaps, and it's differentiable, which you can basically just kind of eyeball by checking its smoothness. So basically, if it's smooth, it's going to be differentiable. Now, let's think about what this is saying. These are just the endpoints. So think of this as like a y2. Well, let me actually put it over here. So let's think of this as like x2 comma y2, and this is like x1 y1. So going back to like the slope, back in your algebra middle school days, we learned that the slope is equal to the difference in the y coordinates, y2 minus y1 over x2 minus x1. So what you would do is draw like a straight line connecting them. Because typically you'd want to look at a slope triangle when you're first learning this, but all we're looking at is the slope of this line here. So this line here is basically this side here. Or I'm sorry, the slope of this line is going to be this side of the equation. Now, what this side is saying is that there's going to be another line that's parallel to this line where it's going to go through one point on the graph between A and B. And we could just kind of look at this conceptually because, again, I remember I literally just drew a random curved line using my ruler. I'm going to try to go out, keeping this parallel. See, right about there. Let me see if I can hold this straight. Come on, here we go. So there's a point right here. We call that C. Let me draw it more straight. This point here is going to be C f of C. And since this line here only touches the function at one point, that's known as the tangent line, remember? And the slope of this line is the derivative. So this is basically f prime of C. the slope of this line is f prime of c. And this line is parallel to this line. That's what this is saying. Like, it's saying that there's going to have to be a point between the endpoints such that you could draw a tangent line with the same slope as the line that goes through the endpoints. If that can click, it's going to be pretty simple to just, work with this. So let's actually draw one that's going to be a little more, up and down, a little more crazier. Because it really helps if you do this and just get the concept to click, and you don't feel like you're memorizing as much as crap. Oh crap. Oops. Try another graph like this. So I advise you to try this on your own, on your own notes. Let me make this axis a little bit more wide. So let's say I'm going all the way from A to B. And I'm going to do this. I'm going to draw a graph that goes like this. It goes like that, and like that, and like that, and like that. So then A would be like, let's say A is veering off like over here. This will be A f of A. Over here would be some with like B f of B. It kind of drew a little crooked. I shouldn't draw it like that. Let me fix this. I'm going to draw it more like that. Yeah. I'm in trouble looking at this. Okay, so that's about right. Now, oh man, it doesn't even reach. I can make it reach. So if I was to connect these points right here. Come on. All right, so here I have another line. This is going to be the right side of the equation. It's basically saying there's going to be points between A and B that I can have tangent lines that are going to be parallel to this line. And let's see where that would be. We could probably have one. Let's go. I'm going to guess it's probably, yeah, so it's probably going to be one like over here. Add some more space. It would make sense to have one like up here, right? And then there's probably going to be one over here too. And then going down, down, down. Just eyeballing it. And look, you see, like, I can call this point C, f of C. I can call this D, f of D, E, f of E. I drew a random graph, as long as it was, met these two conditions, a random graph that was continuous and smooth, and I found, 3 points that we can say have tangent lines parallel to the original line going through the endpoints. That's what the mean value theorem is basically saying. This is a good way for you to understand the concept, because once that clicks, the math behind it is pretty easy. So let's go through an example where we can demonstrate this. Mean value theorem. Okay, so let's see what we got here. X squared minus x plus 1. X squared minus x plus 1 from -1 to 4. So we're going to find all numbers C that satisfy the mean value theorem. So find all values C that satisfy the mean value theorem, MVT. Let's block this off a little bit here. Okay, so the first thing always is to show that these two conditions are met. On your AP exam, I would recommend that you kind of just write them out kind of separately to show that you have two conditions that you're actually checking. So all we would say is that since this is a polynomial, polynomials are by their characteristic, we defined them earlier as being continuous and differentiable on these two types of intervals. So we can just say since it's a weird star, since f is a polynomial, it is continuous on, can you see? Yeah. On -1, 4, this is a closed interval. That's one condition. Let me put a check mark in red actually. On 1, 4. And differentiable on the open interval -1, 4. So just doing something like that will be enough. The graders just want to know that you do this check before you go to the equation. So what we're going to now do is basically find a value where the derivative at that value is going to be equal to the difference in this. So let's make this more clear. So in this case, we have A is -1, B is 4. So let's first work in this side out. So then f of B, we got f of 4 minus f of -1 over 4 minus -1. F of 4 will be 16 minus 4, 12. 16, 12 plus 13 minus -1 squared, so 1 plus 1, 2, 3 over 5, so 13 minus 3, so 10 over 5, so 2. Okay, so we want to find a value of x between -1 and 4, where if we were to take the derivative at that value, we would get 2. So find first the derivative of the function. So let's look at f of x, f prime of x in general would be 2x minus 1. Now we want to find this x value, which we're going to call c, and we're going to set this equal to 2. So we simply solve for this. We'll get 2c minus 1, so 2c equals 3. So c equals 3/2. So this should be between the endpoints, and yeah, it definitely is, because 3/2 is just 1.5. 1.5 is definitely between -1 and 4. So we basically showed that the mean value theorem works. So let's just write this a little more formally. So you write since C equals 3/2 and lies in -1/4. The mean value theorem is satisfied. There we go. What do you think, Pepe? Pretty cool, yeah. Yeah, no worries. I know this is gonna be a little complicated at first. No problem. Anyways, so I hope that helps. Let me know if you guys have any questions in the comment section. I'm always trying my best to get better at this teaching gig. But if it's helpful, make sure you subscribe. Tell your friends, tell your peoples, and feedback is always helpful. And I'll see you guys in the next video. Bye, guys.